Hello and welcome to my new tutorial. This isn't tutorial where we are going to learn how to do some things in Proteus. We already did this, but in my lectures, in previous lectures when I talked about relays. But now I'm gonna explain why do we put a diode always in parallel with the DC relay. So you remember when we had this circuit, this was the sixth lecture, when the coil is energized, when the current goes through, and if there is a good amount of voltage here, then this relay, where here we have a ferromagnetic material, is gonna check this node, so it's gonna be a circuit. This one is gonna be open circuit, and this one can be a closed circuit. And when this is switched off, the coil is de-energized and goes back to this first here node. So when I run the program, when I run the simulation, like so, it could be better maybe if I show you the current. Yes, if I show you the current. Go system and system set animation options. I'll show you the current. Now, uh, when there is no electricity here, this coil is de-energized, and here you have a battery, and here you have a current goes to this one and to the ground, but it doesn't go to this one because there is no, here we have open circuit. And now when we close the switch, here you can see that the coil is energized and it attracts this one. Now, as you can see, there is no, and this lamp is now turned on because the current is going through this lamp. Now you ask, why do we use this diode in parallel with this relay? I'm gonna show you. So here we have this transient suppression with feedback diodes. As you can see, when the current when current flowing through an inductor is suddenly switched off, and inductor is suddenly switched off, the collapsing magnetic field will generate a high voltage spike in the inductor's coils. So when you have a current going through this relay, and it energizes and it produces a magnetic field. And when you close the circuit, when you open the switch, there is gonna be an inductive spike. The magnetic field is gonna produce a voltage that can be about, with an amplitude of the hundreds or even thousands of volts. This is particularly common with relay coils. A diode, referred to as a flyback diode, for this type of application, placed across the relay coil, can protect neighboring circuitry by providing a short circuit for the high voltage spike. So when there is a flyback, there we have to provide a short circuit so that wouldn't be any inductive spikes. And now you can see that here this diode with this relay coil without a diode is gonna suppress this inductive spike. Its amplitude is going to be just 0.6 volts. It also protects the relay's mechanical contacts, which often get viciously slapped shut during an inductive spike. Notice, however, the diode is ineffective during turn-on time. Select a rectifier diode with sufficient power ratings 1N40011, 1N4002, etc. Schottky rectifiers are well too. For example, 1N5818. So we need a diode to provide a short circuit because it can really damage the circuit if you don't put a diode in parallel with the relay. So in Proteus, you don't actually see those inductive spikes, but if you are doing a project or you work for someone and he wants a circuit with a relay, you always put a diode here. It doesn't simulate those inductive spikes here, but if you do a printed circuit board, if you do in some project, put a diode here. It's just gonna save a circuit, because in real life this relay can get uh, it can broke some things. It can have some uh, bad stuff can happen if you don't have a diode in parallel. So that's it for this lecture. Please, I mean, not, you don't have to do anything. Just, if you want, you can like this video. You can subscribe if you want. I don't really care. I hope you learned something from me. So see you in my next lecture. Goodbye.